your investigation, hopefully you notice that there is a relationship with the end behavior between the leading coefficient and the degree. So if you have an even degree and a positive leading coefficient, then that means that both ends of your graph will go up, however that looks. If I have even degree, but it's a negative leading coefficient, then both ends are going to go down. And then we could have any sort of wiggle going around. The importance is both ends going down. If I have an odd degree, odd means opposite. And what the leading coefficient tells you is what the right side is doing. So the right side is going up, which means the left side is going down. And we could have any sort of thing happening in between all of that. I could have a bunch of stuff. Odd negative means the right side is going down, which means the left side is going up. So what you can think about is, especially with odd, is kind of think about it as slope. If it's odd positive, it means overall my slope going left to right is positive. If overall I'm going down from left to right, then it has a negative leading coefficient. So I remember this as even degree is equal. They're doing the same thing. Odd degree is opposite. My ends do the opposite thing. Then down here we have our steps to either sketch or to write equations. The first thing we're going to focus on today is writing equations. So my first thing to do when I'm writing an equation is take my zeros. Remember, zeros are just x-intercepts. Take those and write it as factors. So if I have an x-intercept at 1, my first step is to write that as a factor, which would be x minus 1. Then I put the exponent based on the shape at each 0. Remembering if it passes through, just straight passes through, that's an exponent of 1 or multiplicity of 1. If it looks like a little parabola right at the x-intercept, it's a squared. And if it looks like cubic right at the 0, then you would put to the third power. Check your overall shape. By that I mean, are your degrees matching? If it is both sides going to the same spot, do you have an even degree? And if you have both or each end going differently, do you have an odd degree if you add up our exponents? And then you're going to check if you need a negative leading coefficient. So are both ends going down? Is the right end going down? For honors, we're going to be finding also our exact a value. So we're going to be using either the y-intercept or another given point. So if I just have the graph, I can use the y-intercept. Or you might be given a point to plug in for x and y to solve for a. This is exactly like what we did with quadratics. When we get to sketching, our first step is to factor. Guess what? You're in Algebra 2. We will already have the factoring done. We're going to find our y-intercept, identify our degree as even or odd, and our leading coefficient as positive or negative. Sketch a mini graph. What do I mean by a mini graph? I mean what we have right up here. This helps me know where to start and end when I do a sign chart. Then we're going to identify our zeros, that's x-intercepts, their multiplicity, that's based on the exponent, and behavior. By that I mean, is it linear, quadratic, or cubic? The higher the degree is, the more squished it is. So if I have to the 4th power, it looks like quadratic, but more squished. Something to the 5th power looks cubic, but more squished. We're going to scale our axes. So I just mean you need to put your little marks on your x and y axes, graph your zeros, and we're going to use our mini graph to know where to start. And then touch our zeros as identified in 5. And we're really going to explicitly do this with something called a sign chart.